Good morning. In the last class, we have gone through the product matrix, and under this, we have gone through cyclomatic complexity measure. This is proposed by MATCAP, we know that, and this is the formula E minus En plus P. And just to summarize this, what you are doing is you are constructing a basic block. Using a basic block, you are constructing, right, the graph, okay, and that graph, okay, is basically it uses basic block in connecting different basic block. And basic block has a property that if one statement is executed, then every statement in that basic block is executed, and always jump is to the beginning of the basic block. With these two property, you are constructing the graph, right? Thus, and the very purpose of this is to understand the complexity of a module, and it has been said that it should be kept below 10, right? This number should be kept, and this number always indicates, right, a number of decision points plus 1. And it is also used to as a number of path that should be tested during, right, testing, right? Okay, please look into that. This is the very important thing from the examination point of view also, right? Maybe path testing, right? For the following program, okay, generate the test cases that will test the path. That means you should know how many paths are there. How do you do that? It is using cyclomatic number. You find out and identify the path in a graph, and for every path, okay, come out with the input combination so that the flow of execution will go through that, right? This is what we are seeing, and an example. The example is this, right? Here is such a kind of an input will be given to you. Hope Ashish, you updated our in-class question bank also.
Yes, sir.
Right. Now consider this graph. Okay, after constructing this graph, simply you'll find out 4, right, number, cyclomatic complexity number. What is that 4 is? This is the one, this is another one, this is, okay, third one, right? This is, okay, 4th one, right? This is how we'll find the number of path in this. Okay, is that clear? Is that clear? From examination point of view of IA3, please remember that this is a very important thing. Ashish.
Yes, sir.
Okay, that we have seen, and here is a one case study argument. Please go through that. Now we will go through the when we talk about the, okay, for example, see, let me share with you the syllabus, right? There are many terms that we use. Okay, we were talking about the path testing, okay, is that clear? Path testing. In order to test the path, you need a number of paths, and what all those paths, and we have to give that input to the program so that flow of execution will go through that particular those path, and combination of the input, right, is what we call as a test case to ensure the path testing. Is that clear? Is that clear? Hello, Ashish?
Yes, sir.
Right. Now let's get into, okay, in orderly manner. In fact, I wanted to go for the statement testing, but rather than that, now let's get into equivalence partitioning, which we have referred before once. Am I right? Which we have referred once. Do you
Yes, sir.
remember?
Yes, sir.
Right. Okay, let me recollect with more concrete examples, okay, so that you can understand better. Right. So I will take you through the equivalence partitioning, right? Please look into that, and you can refer this in the internet and search. Otherwise, you can use the textbook also mentioned in the syllabus. Okay, let's see that one, which whether we have mentioned any book in the syllabus or not. Okay, about this, let me check. It is not the reference book, right? Somerville Pressman. I will, okay, give you one more book. Okay, please refer that, or you can refer the internet. Got it? Yes. Now let's look into equivalence partitioning. This is again very simple aspect of that. For example, now look at that. When you have an input domain, say for example age, right? I have say if statement, assume, I'll write it on this. Okay, now consider that, okay, you have a programming statement. If, say, age, I'll write, okay, age as age here, greater than 18, right? Then what you do something here, right? Otherwise, something else. Okay, this is the else part. Are you getting this particular code? Are you visualizing this, Ashish?
Yes, sir.
Right, right. When you visualize this, okay, age greater than 18, then now what happens is, see, when I look at the age, now this is the number, right? This will, okay, move from your negative number, okay, negative large possible number to large positive number. Am I right? Right? And
Yeah.
suppose you
Yes.
have a, right, 18, right? See, greater than 18 is the one which falls in this particular group, and lesser equal to 18, right? I said greater than 18. This and including 18, please look into that. This falls under the another category, right? This is, okay, partition 1, I'll say. This is partition 2. This is partition 2. Now what you are supposed to do is, right, if the code is, right, if, again I'll write it because it has gone, if, right, age greater than 18, right, then you will do set of statements, say S1, right, else, right, else you will do set of statements S2. Now what happens is, right, in order to test this one, I have to give an input, okay, here. My test case T1, okay, is, right, the value of A equal to, taken from one of this partition, right, that is equal to any one representative, not all the number. So I'll take, for example, 20. Right. Then what is an expected output? Expected output, right? Expected output is, right, the statement S1 is being executed. Maybe issue the insurance, issue whatever that is there. Now test case 2 is taken from another partition, right? That is from P1, right? I'll take the age, say, representing one number, a number representing the entire partition P1. I'll take it, say, 10. 10, 7, 8, minus 2, minus all one and the same. But minus 1 to age doesn't make sense at all, right? Then the expected output is, right, from the statement S2, indicating that insurance cannot be issued, right? So this is the design. This is the test case design with the proper input. Test case ID. This is called test case ID. Okay, all this column, this column, right? It could be, because here there is only one input, so one column. If there are more than one input is required, you have multiple columns here, right? So this is the input, right? This is the test case ID, right? This is the test case ID. This is the input, and this is an expected output. Expected output could be message, could be actions, could be whatever that is there. So this is how you prepare a table. This is how you prepare a table, and you write the test case for that, equivalence partitioning, right? And that means one sample input. The sample input is this. One sample input combination could be, here is only one variable. There could be multiple variables. All this will fall in the same column with multiple columns split into that, right? So one combination of that input will, okay, is, okay, for partition, right, P2. This is for partition P1, right? So this is called equivalence partitioning. Are you okay with this?
Yes, sir.
Okay.
Yes, sir.
Right. Oh, Arpita, good. Good morning. Right, whole class. Right. Now let's look into some more examples. Okay. This is a very important thing. Right. Then we'll see what other examples, right, which I need to refer. Please look into that. Right. Now the property is that the equivalence class are created assuming that programs under the test exhibit the same behavior on all elements. I told you partition P1 where age greater than 18, whether you give 19, 20, 21, 22, 23 or 200, 300, whatever the number you give from that partition, behavior is same. So we take one representative. You cannot do infinite testing for all possible input. So equivalence partitioning will help you to reduce the number of test cases, right? One test case per partition. Is that clear? Right?
Yes, sir.
Right. And
Yes,
look
sir.
at that, the fault targeted. Every partition will target certain things. For example, okay, in the same example, whatever we have used, okay, let me share with you, right? Here is a number, right? I told you here is 18, right? And remember that this partition targets for issual of insurance or license, and this partition, okay, will target for okay, non-issual of license or whatever it is. Are you clear about that? Are you clear about that?
Yes, sir.
Right. That's what it said. Okay, faults are targeted. That means, right, every subset, right, is required to behave differently. Then only it is we call it a partition. In our case, as I told you here, right, age 18, this partition and this partition, the program is supposed to behave differently, no? This partition P1 and P2, it is supposed to behave differently. Are you clear?
Yes, sir.
Right.
Yes, sir.
That's good. That's good, right? Uh, Equivalence class partitioning select the tests that target any faults. True. Please remember, I repeat once again, okay, for the input domain, these are all partition. This is one partition, this is another partition. This, okay, whatever that is the partition you have it, right? Each one, right, exhibit a unique behavior targeting something in the program, right? Okay. Uh, Now look at that. This is another beautiful example. I'm giving a simple example, but little complex example I'll be giving it for in the examination. Right? Consider an application A that takes an integer denoted by age, same thing as input. Let us suppose that the only legal values of age are in the range of 1 to 120. The set of input values is now divided into two things, right? That's what I was telling about that. 1 to 20 is one partition. All other integers, okay, fall in like incorrect inputs, right? This is how the partition is to be done, right? Now let's get into some other examples, right? Um, right. It may so happen that there may be several partitions. The behavior of the system, right? Sometimes for the value 60 to 120, senior citizen may be different. Non-senior citizen may be different, right? And specially privileged old age people greater than 120 years, probably something may be different. And age less than one, maybe baby, all babies, right? There's probably your software may be treating something different, right? But age, okay, less than zero doesn't make a sense, right? That kind of things you need to ensure in your program. Okay, enter your age. If I enter my age is -10, will it make sense? It is a illogical thing. Age has to be greater than zero, right? Then it gets into, right, whatever it is, right? So if there are requirements, right, for the program to behave differently when age less than one, okay, when age is between this, when age is this, when age is between that, if there are different treatment is there, then you have to take a sample one from each partition and feed it to your program and check the behavior, right? Please remember that. And always test cases are represented in the form of a table. I told you, right? Test, okay, this is the heading, test case ID. Let's call this as a test case ID. Then all input, assume that you are giving input as a, okay, then B, right, then C, all possible inputs, right? Then expected output, I'll write it here. I think you are seeing that one in case of, right, the test cases based on sequence diagram and all we have written, no? Ashish, am I right? Ashish?
Yes, sir. Yes, sir.
Right, that table. Now look at that. This test case ID number T1, I'll say. Then A value is say 0, B value is 1, C value is 2. This ABC together will decide one partition, assume. Then expected output could be right erroneous. The message error message, right? I can say error message 1 indicating that text, I'll write it. Then test case number 2, right? Could be some combination of something, right? Each test case will focus on a particular partition. Please remember that. And if there is only one input, then other things you just ignore, right? In this case, probably age is only one input. This is how these each row we call as a test cases. And this entire table test case design a solution for given problem. Are you clear about this? Ashish, Arpita?
Yes, sir.
Right,
Yes,
that's
sir.
good. That's good.
Yes, sir.
Here is an example I'll give to you. Right, all of you copy this. I will not give a solution for this. I wanted you to try this before you get into the third eye. Okay, take
So
it
we'll take screenshots, sir.
and put it in class, okay, question bank and mark it as important.
Yes,
Everyone must try this,
yes, sir.
right? Such a similar thing you will get it, not this, such a similar thing. I will not help you thus, but you can take your seniors' help who are in 7th semester studying software testing. They are studying software testing separately, software engineering separately, but you people are studying both in one course only. Got it? Ashish, are you okay?
Yes,
Yes,
sir.
sir. I've taken the screenshot.
Right. I think with this input, you should be in the position to get into. Let's see that one, how well you do it. Right?
Yes, sir.
Right? Okay. Then let's look into the syllabus, what all we were talking all about. Right? So equivalence partitioning, okay, that we have gone through. Model-based testing we have gone through. And testing, okay, terminology we have gone through, right? Test automation, test case design, right? The terminology we have gone through, right? Then we will talk about the boundary value analysis and all that we will see. Now let's look into statement testing, right? Statement testing. Just 1 minute, right? Under the structural testing, it is about the structure of the program, right? We study branch testing, condition testing, path testing. Path testing already we referred it. Am I right? Path testing we have referred it. Am I right?
Yes, sir.
You have to draw the control flow graph, CFG. Control flow graph for given program using uh, right basic block. That is also important from the examination. Please remember. You'll be given a program and you'll be asked to construct a basic block, construct a control flow graph and identify number of path and design the test cases. This is question surely in third eye. But which program that is not known to you, right? Ashish, note down that also in your okay in class question bank. For the given program, right? Do the following, Ashish. For the given program, do the following. First one, okay, construct control flow graph. Construct
So for the given program,
for the given program, okay, do the following. First one, construct control flow graph CFG using basic blocks. Right? Second one, okay, identify cyclomatic complexity number of the graph. Right?
so
Identify
cyclomatic.
cyclomatic complexity number of the graph. Third one. Design the test cases. Design the minimum number of test cases. Design the minimum number of test cases to cover all path. That means you need to have a four. If the cyclomatic complexity number is 4, then you need to have 4 test cases. Got it? What is the test case? Already I have told you. It is in the form of the table. All input combination which will need to execute that particular path covers that path. Like that, all path should be covered for all different inputs. Right? Is it okay?
Yes.
Right. These are the
Yes.
two important
To
things.
cover all paths, right?
To cover all paths.
Yes.
Right, that is a path testing. Right, now let's look into some other aspect of this today and get into. Still, we have a time. Right, I'll skip all these things. Theoretical things not required. I'll take you now. Look at that. Now you are getting into the statement testing. Right, what do you mean by statement? Right, statement is every statement you write in the program. Right, for example, look into that. I will write, okay, C equal to, okay, X, right, minus Y, a C programming language. Then what I do is write, okay, Z equal to, right, C divided by 2. I'll keep on writing programming statement like this. And each one, I don't say each line, sorry, each one ended by semicolon is called statement. Right? Don't misunderstand that. The entire line horizontally, because you can write horizontally many statements with the same line. Am I right, Ashish?
Yes, sir.
Right? Every statement ended by a statement is an expression ended by semicolon. Right?
Yes.
So look at that. Right? There is something called coverage. Right? Coverage is the executed statement, number of statements executed divided by total number of statements. Divided by total number of statements. Are you getting this? So I will give one input, say A equal to, right, age equal to, say 10, right, age equal to 10. Now please look into that. Okay, I'll write this, my program. If, all of you refer it, if, right, age greater than 18, right, then I'll begin, I'll say statement S1, statement S2, right, else, right, open bracket, I'll write statement S3, statement S4, right. Now how many statements are there? Right, now what I'll do is I'll take a test case T1. Test case T1 equal to, right, what is that? Right, I'll say A equal to 20 and expected output is issue, okay, license. I'm not writing in the table, in the table form. Now for this test case, what is the coverage? Okay, coverage is executed statement. When I give A equal to 20, what all the statement get executed? Okay, this is 20, A value is 20. Right? 20 greater than 18, yes, then S1 is executed, S2 is executed, but S3 and S4 are not executed. Am I right, Ashish?
Yes, sir.
Right. For T1, for only T1, right, what is the coverage is executed statements are 2 and total statements available are 4, right, into, right, 100, right, equal to, right, it is how much? 50%. Am I right? Am I right?
Yes, sir.
Yes, sir.
Right. So that means the coverage, okay, of statement coverage for the test case T1 is 50%. That means it doesn't cover all. Okay, it is not adequate. It is not complete. Right. So what I'll do is I'll prepare one more test case. Okay, T2 equal to, then I'll say A equal to, right? What happens? I mean, consider that A equal to 10. This also has a 50%, okay, this one, no? Right? And put together, when I say put together T1 and T2, what is the coverage? Coverage is, right, okay, 4 statement divided by 4 is 100% statement coverage. Am I right? Am I right?
Yes, sir. Yes.
Yes, sir.
Right. Right. So one of the term is coverage, and under statement it is called statement coverage. Under decision it is called decision coverage. Under condition it is called condition coverage. We will see all these things in the subsequent classes. Right? So adequacy criterion, each statement or the node in the CFG, control flow graph, remember already we have gone through the control flow graph, must be executed at least once, right? And for that we use a coverage, the number of executed statement divided by number of statement. If it is 100%, then that set of test cases are adequate, right? Right? Are you okay?
Yes, sir.
Yes, sir.
Now please look at that. The rationale behind this has been given. A fault in a statement can only be revealed by executing that faulty statement. Now, am I right?
Yes, sir. We won't know otherwise.
Right. If there is a fault in the kitchen room, right, you have to go to kitchen room and test it. No, okay, you cannot test that in a bathroom. Am I right? Got it?
True, sir.
I'm talking about the water flow pipe. So until that statement in the kitchen room, that junction, that tap is a statement that is tested, right? Okay, it doesn't reveal. Got it? So the set of test cases, whatever you design, it should, right, have 100% statement coverage. That collection of, okay, test cases, okay, become minimum number of such things you need to identify, which will make 100% statement coverage. Right? Please note down. Please note down. In class question bank, all these are important because in the final examination you'll get one full question on this. Remember, and it's very easy to do this, and you'll get 100% marks. Right? For the given following program, identify the minimum number of test cases to ensure. Ashish, are you collecting?
Yes, sir. I'm writing.
Identify minimum number of test cases to ensure 100%. First one, Roman first one, statement coverage. Second Roman thing, condition coverage. Third one, decision coverage.
So, what was the first one?
Statement coverage, 100%. First one is statement coverage. Second
Yes, sir.
one is decision coverage.
Yes, sir.
Third one is condition coverage.
Yes.
Okay. Fourth one is path coverage.
Yes.
So in all the cases, condition, decision, path, it is same statement. Number of paths, okay, number of path executed divided by total number of paths. Condition, number of condition executed divided by total number of conditions. In case of decision, number of decision executed divided by total number of decision. Are you getting it? Okay.
Yes.
Yes or no? But we will cover all the things with example. Don't worry. Right? But this statement coverage, this simple example we have taken, if age greater than, see, look at that. This example we have taken, you remember it, right? If age greater than 18, then execute statement S1, S2, else execute statement S3 and S4. This is a small program. Identify the test cases to have 100% statement coverage. Test case 2, T1 and T2. That's all. Right?
Yes, sir.
Right? That's good. That's good. Right? So this is about the statement coverage. Now let me get into the next one, right? So you can take a screenshot at a regular interval, all of you. Right? Ask people not to miss these classes because you have a 100% assured mark and your IE3 based heavily on these things. Right? Shall I go to the next one?
Yes, sir. I've taken a screenshot. Should I put this in there?
Yes, okay, you can say that one hint. You say hint and you put it. Okay?
Okay. Yeah.
And the statement coverage, similarly, we replace statement by decision, replace statement by condition, path and all, they become statement coverage, decision coverage, path coverage, condition coverage, etc. Right? Okay?
Yes.
Okay, fine, that's good. Right, right. Now look at that. Sometimes such a kind of a big flow, you will get it. Right? We'll skip it. I'll skip it. Right? Now branch testing. Okay, branch coverage. You can add Roman 1, 2, 3, 4. No, you have written branch. Okay, branch coverage, statement coverage, decision coverage, right? Condition coverage, path coverage, branch coverage, branch and path goes same, right? Now let's look into the condition, right? This is very important thing, right? Right? Now look at that branch coverage exposes the fault in how a computation has been decomposed into cases, right? Branch. If it is true, go there. If it is not true, continue this one. This is the branch, right? Condition coverage considers the case analysis in more detail. Individual conditions. See, for example, if at all you have something, right, I will write here. All of you look into that, right? If you have a age greater than 18, right, and something, some parameter b equal to 50, as in okay something. Now what happens is I give an input. Now this is one condition, this is another condition, right? This is another condition. Are you clear? Ashish, Arpita.
Yes,
Yes,
sir.
sir.
Right, now what happens is, right, I give input age equal to say 10, then this condition is being covered. What about this condition? This condition is not being tested at all. Hope how C programming work, you know. If this is false, it doesn't test because this is an AND operation. Am I right?
Yes, sir.
Yes, right. So if age greater than, I mean, if I give input 10, this condition is tested. But what about this condition? Right? Put together we call is a decision, right? Okay, if this is true, then statement S1 is executed, else, right, again flower bracket in that set of statements. This entire thing is one decision, right? Decision is made up of several conditions. Got it? I need to have a test case so that this condition is also taken care, this condition is also taken care, all things are to do. So what are the possibilities, right? In order to ensure this, I'll take, now look at that, I have input parameter age, input parameter under is B, as in A is age, B is some other parameter. I will take, okay, A equal to 10, I'll take it, right? A equal to say 20, I'll take it. A equal to 20, then B equal to, right? Something, okay, whatever that is there. It will ensure that both are tested. This one thing will ensure both, right? Are you getting this? Right.
Yes.
Yes, sir.
Suppose A equal to, I'll say take 8. then it doesn't matter. Whatever the value you take it, this is not being executed at all. Right? Are you clear?
Yes.
Right. So you have to build all possible combination like a truth table. Wherever the things are okay, redundant one, you should ignore. Right? Understood.
Yes. Got it.
So every condition you have to ensure that failure what happens, success what happens. This is in case of success. This is condition C1, I'll say condition C2. Right? C1 is success because I'm taking 20 and okay, B, right? C2 is failure. So one of the combination is I have to take A 20 success, B is 10 failure. Then A is 20, right? Then B is right, say success, I'll take 60. Right. Then what I'll do is, right, A equal to failure, I'll take it, 8, right? B doesn't matter because that's not executed at all. So these are the minimum 3, okay, test case I need to have it to ensure, right? That's, are you clear about that? Are you clear?
Yes.
A test case is being built in order to cover the statement coverage. But as for the condition is coverage concerned, this is taken care, this is taken care. Where? This. Right? Only in one. The condition is tested. Right? It is executed once. Right? Number of conditions executed. Right? Are you clear?
Yes.
Yes, sir.
Right. So condition testing is okay, truth value taken by all basic conditions divided by basic conditions. Truth value taken. So in previous example, I told you, please remember, right? Please remember, I said that one A value is okay 20, B value is 10. I said it takes care of the truth value of age greater than 18. It will take care of the truth value of, I mean, you take a 60. Okay, truth value of this, right? That's the end of that. That's the end of that. So condition coverage is truth value taken by all basic condition, right? Thus into 2 into basic conditions, number of basic condition. Why? Because right, true and false. Every condition is true and false, you know. Am I right? Yes.
Yes,
Yes.
sir.
Yes, sir.
Right. So look at that. Each basic condition must be executed at least once. Adequacy.
Yes.
And if you have 100% coverage, okay, 2 into basic condition. That means once you have to execute for true things, when you have to execute for false things, then only it is 100% condition coverage. Conditions are true and false, no?
Yes, sir.
Right. Right. Here is a one, okay, you need to note down, right? And similar kind of example may be given here, right? Okay, find out the number of test cases required to test, right, the following expression. You please note down, snapshot and put it in your in-class question bank.
Yes, sir.
This A or B and this entire thing and C, then this entire thing, right, or D, right, then, right, this entire thing, this and this. It is getting closed shortly, right? So now you need to look into the test cases, how you build test cases. So look at that, A, B, C, D, E, right? Test case 1, when A equal to true, B is redundant, not required, and C equal to true, right? When A equal to true, C equal to true, B doesn't make a difference, right? D doesn't make a difference, and E equal to true, the entire expression is evaluated to be true. Are you clear? This entire expression to be evaluated to be true under the test case 1.
Yes.
Yes, sir.
Right. Now look at that. If A equal to false, right, then B equal to true, C equal to true, and this true. Here also the entire condition is evaluated. Now look at that. Test case 1 and 2, right, ensures that when this is true, what happens? When this is true, what happens? Condition is taken care. This is one condition, this is another condition. Under the both the condition you have to look into. It may so happen that it may not work for this. Very clear? Very
Yes,
clear?
sir.
Yes.
Right. Right? So, right, you need to ensure all these things, all possible combination, right? When A equal to true, okay, B doesn't make a sense. When okay, C equal to false, right? Then B equal to true, right? This entire thing will be true. Am I right? When D equal to true, it means open that, see, okay, it is getting closed. Okay, take this as a screenshot and put it in your in-class okay, question bank.
Yes, sir. Done.
Right. Please do it. We will see that in the next class. Right?
Sure.
It is 1 minute. 1 minute. Stop. I'll stop sharing the screen. There are 32 students participated. We wanted all the people to join. Right? Those who are not joined, refer the video. I'll come to the end of this. Please prepare your entire uh, I2, I3 is based on this. Right?
Yes.
Shall I complete my meeting?
Yes.
Thank you for attending because you have got immediately the training program. In spite of that, you have 15 minutes break time. Okay, get into that. Make use of all opportunities given to you better. Right?
Yes, sir.
Right. Okay, bye.
Thank you, sir.